Oh, man. Good evening, everybody. So tonight we'll be treating chemical equilibrium. If you are here already, let me know. If you are here already, type "I am here" so we can start. I'm not feeling too well today, but I think we must do something. Jamb exam is already here. So if you are here already, type "I am here" so we can start. Okay, I have Busola Olani. Is it only Busola Olani that I have here? Okay, I have Godwin Beauty. Okay, Perpetua is here as well. Wow, just 3 people. People should not forget that we are treating chemical equilibrium today. I was expecting a lot of people to be here. Okay, if you are here, type "I am here" and then tap on your screen. Tap on your screen, double tap on your screen so that you can like the live. Alright, so good evening, everybody. Tonight we'll be discussing chemical equilibrium. And in tonight's class, I'll try my best, I'll try as much as possible to ensure that the class is detailed and simple as possible. You understand? So I want you guys to be tapping on your screen. Just tap on your screen. That's the way to like the live stream. You understand? Just tap on your screen. Okay, so I can see we have a number of people here. So let's start. At first, our topic today is chemical equilibrium. The first thing I'm going to ask you, or the first terminology that you people need to know, is what we call equilibrium. What is equilibrium? Equilibrium. When you say something is in an equilibrium state, or when you say a particular reaction is in an equilibrium state, what do we mean? You understand? I know that many of you guys have not done this particular topic before, so I'll be focusing on the most important parts that Jamb usually ask in Jamb exam. So tap on your screen if you're on this call. Double tap on your screen. Everybody, double tap on your screen, right? So now the thing is that what is equilibrium state? If you say that, okay, somebody said is at rest. Okay, somebody said equilibrium state is something when something is at rest. But do you know that I will shock you that equilibrium state is not only when something is at rest. Equilibrium state is a state of rest or a state of motion of a system. You understand? If a system is at rest or motion, it can be said to be in equilibrium, right? So that tells us that equilibrium can either be static or it can be dynamic. Let me write. That means equilibrium can be static or it can also be dynamic. You understand? When I say something is equal, it can be a body can be at equilibrium at rest, or it can be at equilibrium when it is moving. Like, let me give you an example now. For in physics now, you know, when you have something like in physics, uniform speed. When you have something like uniform speed in physics, uniform speed means that particular object, or that particular, let's say, a vehicle, is covering the same amount of distance in the same time interval. You can see that the motion is somehow in equilibrium. The motion is the same over time, is uniform. I think that's the best word to use. The motion is uniform. So equilibrium does not really, or is not limited to static. It's not only when something is static that is equilibrium. It can also be dynamic. Dynamic means that the thing is in motion, right? The thing is in motion. So now, tonight we'll be discussing chemical equilibrium. So in chemical equilibrium in chemical substances, or equilibrium in chemical reactions, is the dynamic type. Equilibrium in chemical reactions is the dynamic type. That means it's the one that is motion, that is moving. That means something is getting converted to another thing. Like a substance is getting converted to another substance. You understand? Or one other substance is getting converted. So one thing you need to know that in chemical equilibrium, for chemical equilibrium to be involved in a chemical reaction, right? The reaction must be reversible. Everybody type, the reaction must be reversible. Everybody, I want everybody to type it. The reaction must be reversible. If you type this in yourself, maybe that's the way you used to remember. So for a chemical reaction to be in equilibrium, the reaction must be what? It must be reversible. The reaction must be reversible. So that means the chemical process must be reversible. For it to be at equilibrium, it must be reversible. Everybody, the reaction must be reversible. Everybody tap on your screen, tap on your screen. So for any reaction to be in equilibrium, the reaction must be reversible. For example, let me just try to give you guys an example of a reversible reaction. Let me use A. Let me say A is our reactant. Let's say B is another reactant. Let's say to give us C plus D. Right? So you can see I'm giving you guys an example. You see, two reactants. Let's say A and B are the reactants. They react to give us C and D. Right? So if C and D, this is, you can see this sign. This is showing the forward reaction. The reaction is going in the forward direction. You understand? This particular arrow is showing that this is the forward reaction. So you can see this other arrow too. This other arrow is moving towards this side. And this one is telling us that this is the backward reaction. So this arrow, these two arrows, tells us that this reaction is a reversible reaction. It tells us that this reaction is a reversible reaction. So are you getting me? So for something to be in equilibrium, that means as the reactants are getting converted to products, that means the products too are also getting converted back to reactants at the same rate. Are you following me? For a reaction to be at equilibrium, the reactants will be getting converted to the products, and the product will also be getting converted back to the reactants at the same rate. I hope you are following me. That is just the basic explanation of equilibrium state. You understand? Or the equilibrium of a reaction. You know, I gave you guys that for what am I saying? For an element or for a reaction to be in equilibrium, the first thing is that the reaction must be what? Must be reversible. That's the first condition. The reaction must be reversible. Let me give you another condition. This other condition, I've already explained it though while doing my explanation. And the other condition is that the rate of the forward reaction must be equal to the rate of the backward reaction. So everybody type the rate of the forward reaction. The rate of the forward reaction. Forward reaction. Everybody type it. The rate of the forward reaction must, it is a must for the reaction to be said to be at equilibrium. The rate of the forward reaction must be equal to the rate of the backward reaction. Right? For a reaction to be said to be at equilibrium, it must be reversible. You understand? It must be reversible. And the rate of the forward reaction must be equal to the rate of the backward reaction. So, the rate of the forward reaction must be equal to the rate of the backward reaction, right? That is the second factor, or that is the second condition that must be The second condition that must be there for a reaction to be set to be at equilibrium. Let me give you another condition, because all of these things are things that Jamb can just bring out in MCQ. These are questions that Jamb can just ask. They just be like, for a reaction at equilibrium, is the rate of is the forward process equal to the backward process? That's just how it will be. So the rate of forward reaction must be equal to the rate of backward reaction, right? So another factor that you people need to know is that the system must be closed. The system must be closed. If I say the system must be closed, you see this word? You see, I'm putting it in quotes. Closed. The system must be closed. Can anybody tell me why the system has to be closed? Or can anybody tell me a closed system? What do you understand by a closed system? Let me hear from you guys. If they say that a system is closed, what do we mean? If we say that a system is closed, what do we mean? I'm waiting for you guys before we continue. If we say that a system is closed, what do we mean in chemistry? If you are just joining, you are welcome. My name is Max and I teach chemistry here on YouTube for Jamb Science students. If you have not subscribed to my YouTube channel, now is the best time to do so. So what does it mean for a system to be closed? Don't forget to be tapping on your screen. Don't forget to be tapping on your screen. Don't forget to be tapping on your screen so you can like the live class. A natural physical system that does not allow the transfer of matter in and out. You understand? A closed system does not allow the transfer of matter or energy at all, because chemical equilibrium is a dynamic equilibrium. So dynamic equilibrium occurs in a closed system. Good. So in a closed system does not allow the exchange of energy, does not allow the exchange of matter. You understand? So the matter or the energy that starts the reaction must be the same energy that will end the reaction. So we know that we usually say that energy can neither be created nor destroyed. You understand? But can just be converted from one form to another. You understand now? So that is it. The system must be closed. That means there must not be exchange of matter or there must not be exchange of energy, right? Okay. So another condition for a system to be at equilibrium is that the free energy or the free energy change, or we call it the Gibbs free energy, the free energy change, which is delta G, the free energy change, which is Gibbs free energy. Do you people know energetics? Have you people done energetics before? All these endothermic and exothermic reactions. So you should have done exothermic reaction, you should have done heat content, entropy, and Gibbs free energy. If you have not done it, then let me know so I can teach you later after this class. You people know that I'm also a busy person. You people know I'm a medical student. I'm also in medical school, right? So you people know I'm also busy with a lot of things. But I'm trying to just make out time for you guys, eh? If I want to be coming live now, maybe I'll just be coming live on Saturdays alone. So that means we'll have like 4 more Saturdays before you post Jamb exam. The best way to connect or the best way to actually learn together is by watching my YouTube videos. That's the best way. Wow, so you people don't know what Gibbs free energy is. You people have not been taught, or you people have not read energetics on your own. Wow. That means you have not read anything about chemical kinetics. Wow, that means we have a lot to do. Okay, now. Voila. I'm going to teach you guys, sir. But it's definitely not in tonight's class. Definitely not in tonight's class. In tonight's class, we'll be dealing with chemical equilibrium, right? So the Gibbs free energy or the free energy change, which we call delta G. This triangle means delta G. This delta G is what we call free energy change, or we call it the Gibbs free energy change, right? The Gibbs free energy change, delta G, must be equal to 0. So if they ask you in your Jamb exam, or let me ask you myself now. If they ask you delta G, or the Gibbs free energy for a reaction at equilibrium is, what will be your answer? What will be your answer if they ask you that kind of a question? The Gibbs free energy change of a reaction which is at equilibrium is what? What will be your answer? Before you wake up. Wow, my phone is already at 20%. This phone, sha. Wow, is it only one person? Is it only one person that knows the answer? Okay, 0, 0, yeah. It is 0. The Gibbs free energy change for a reaction at equilibrium is always equal to 0, right? Is always equal to 0. So let me say these are the 4 basic laws that you need to know. These are if you remember these 4 basic laws, you should be able to actually understand when an equation or probably a system is in equilibrium, right? Adebisi Olamide, good evening. What's up? You understand? Please tap on your screen so that you can like the live. Tap on your screen so that you can like the live. You should let me know if you want me to teach you energetics. That's all this exothermic reaction, endothermic reaction, and all of those. Because they used to set it inside Jamb. So now, I want us to talk about chemical equilibrium, right? So now, chemical equilibrium can actually be divided into 2. Chemical equilibrium, your phone not like our class, rara. Every time, if it is not at 14%, it will be at 10. It's already at 19% now, safe. You know that I'm always busy with my phone now, so I'm always on my phone. That's why I don't really charge the phone like that. Imagine. So now, we have 2 types of chemical equilibrium, right? We have 2 types. We have the homogeneous equilibria. Everybody type homogeneous equilibria. Everybody type homogeneous equilibria. I believe you people know that equilibria is the plural form of equilibrium. We have the homogeneous equilibria and we have the heterogeneous equilibria. And we have the heterogeneous. These are things that Jamb can ask you. These things are very simple. I'm going to explain both now. Heterogeneous equilibria. See you and this your phone. What was wrong with my phone? You push no why me on. So we have homogeneous equilibria and we also have heterogeneous equilibria. Homogeneous and heterogeneous equilibria, right? So now let me tell you guys the difference between homogeneous equilibria and heterogeneous equilibria, because these are things that you can see in your Jamb exam, right? For homogeneous equilibria, all the compounds, or let me say all the atoms that are taking part in the reaction or all the atoms that are in the system, they all belong, or they are in the same state. Let me say all, let me just say all species, or let me say atoms, or let me say molecules, like all molecules are in the same physical state. I will explain. When I say that they are in the same physical state, I mean that maybe all of them they are solid, all of them they are liquid, all of them they are gas. Let me give you an example. Let me give you an example of an homogeneous equilibrium, right? Let me give you an example of homogeneous equilibrium. An example of homogeneous equilibrium is when hydrogen gas, right? Hydrogen gas is reacting with iodine in form of gas. To give, this is a reversible reaction, right? You remember that a reaction that is in equilibrium is always reversible. Don't forget that. 2Hi, hydrogen iodide. You see this reaction? Right? Hydrogen is in gas. The physical state of hydrogen gas is gaseous. The physical state of this iodine gas is in gaseous, and even hydrogen iodide, you can see it's also in gas form. So all of them are in gaseous form. So this is an homogeneous equilibrium. You can see the reaction is forward and backward. It's a reversible reaction, right? You understand? It's a reversible reaction. Do you get me? If you are following me, type yes. If you are following me, type I am following, before I continue to the heterogeneous equilibrium. If you are following me, type I am following. If you are watching this video anytime, if it is now or later after I've posted it, don't forget to subscribe to my YouTube channel, because that is the best way to support me. The best way to support me is by subscribing to my YouTube channel, by liking this video, and also by commenting if you have any questions. Okay, so let us continue. Now, for heterogeneous equilibria, it's basically simple if you understand homogeneous equilibria. I said that all the species in homogeneous equilibria are in the same state. So for heterogeneous, like the word hetero, different. So the species that are taking part in these reactions, they are in different physical states. So let me just write different physical states, right? Who is singing Arikel there? Who is singing Arikel with me? You people should not sing this song with me. So they are in different states, right? Let me give you guys an example. Let me give you guys an example of an heterogeneous equilibria, right? Let's say limestone CaCO3 reacting, or let's say breaking down in a reversible format. CaCO3 is solid. I believe we all know that CaCO3 is solid. If it's going in a reversible reaction to give calcium oxide, which is also solid, plus CO2, which is a gas, CO2 gas. You can see this is an heterogeneous equilibria. Why? Can anybody tell me why this is an heterogeneous equilibria? Type it in the comments. If you are watching this live stream anytime, even if it is now or later when I've uploaded it, I want you to type why this particular question is, or this particular equation is an heterogeneous equilibria, or is a form of heterogeneous equilibrium. The best way to support this life is by tapping your screen. Tap your screen and like this life now. Why are you people being are you people stingy with liking? You people don't know that if you like this life, you tap on the screen, like double tap on the screen now. YouTube will so that these people like what they are doing now. They like this life. So it will be like so many people that want to watch it afterwards, they know that a lot of people have watched this and they really enjoyed it. You understand that kind of stuff now. So this is an heterogeneous equilibrium, or this is a form of heterogeneous equilibrium, because the species or the compounds and molecules that are reacting are not in the same state, right? Calcium carbonate, which is our normal limestone, CaCO3, is in solid form, right? Our CaO, which is our calcium oxide, is also in solid form. So this one and this one, they're in the same form. But you can see the CO2, our our carbon dioxide, CO2, carbon dioxide, is in gaseous form. So they are in different physical states, right? They are in different physical states. So that is why this is called that's why this is called heterogeneous equilibrium. Who is asking who is Mayarike? Mayarike, I've not met her. I pray that God will give me my Mayarike, my wife. I'm looking for my wife. So that's that for that. If you want to screenshot this, you can screenshot. But don't worry, also I'll be posting the recording, so you can always watch it anytime you feel like watching before we move to the next thing. Right? I want to ask you guys a question first. I want to see what people can say. What is a catalyst? I want to share from you people. What is a catalyst? Tell me your own meaning of a catalyst. What is a catalyst? I'm waiting on everybody. Type your answer. Type your answer while I grab my power bank. What was wrong with this YouTube now? They want to start with their orientation thing again. Oh. I'm coming. Let me grab my power bank. I don't know why YouTube used to do this. This used to stress me with this their camera thing. Come, let me grab my power bank so I can be charging. Of course. So some people are talking about what catalyst is. Okay. Some people say that catalyst increases the rate of a chemical reaction. Some people say that it speeds or slows down a reaction. Okay. Some people say that speeding up the rate of a reaction. Okay. Just 3 people. They alter chemical reaction. Okay, this makes sense. A substance that increases the rate of a chemical reaction without itself undergoing any permanent chemical change. This makes sense. But something is actually missing in this particular one by Noah. It increases the rate of a chemical reaction. See, I want you guys to know something. Yes, catalysts increase the rate of a chemical reaction. Yes. Also, catalysts decrease the rate of a chemical reaction. Don't limit yourself to increase. The best word to use is that a catalyst alters. That means it changes the rate of the reaction. It can decide to increase to speed up the reaction, or it can even decide to slow down the reaction. So it's both ways. You understand? Do you get me? It can decide to lower the activation energy of a particular reaction. You understand? It can speed up a chemical reaction. It can also slow down a chemical reaction. Right? And another thing about catalyst is that when catalyst does its job, it is not chemically changed. It is not chemically altered. It just performs its job and is not altered in any form. You understand? So a catalyst alters the rate of a chemical reaction, right? So it's not only speed up. So it will not be consumed by the reaction or permanently altered in the process. You understand? So its own job is just to alter the rate of reaction, either to increase it or to slow down the reaction. Hope you get me. There's something I wanted to ask you people. Why did I forget? I wanted to ask you people one thing about catalysts like this. Most catalysts, belong to which which particular which particular let me say which group of a periodic table, or let's say which set of elements do most catalysts belong to? Most catalysts, they belong to which set of elements, or what set of elements? What set of elements in the periodic table do we have the most catalysts? What set of elements do we have the most catalysts? Somebody said group 3, somebody said group 7. Somebody said transition metals. Yes, transition metals. We have catalysts in group 3 too, but the particular place that we have most catalysts is the transition metals. Transition metals. Transition metals, they have plenty catalysts. Transition metals, they have plenty catalysts. You have chromium, you have vanadium, you have manganese, and many others. So transition metals, usually many of them, they usually act as catalysts, right? Even iron self, they work as catalysts. You understand? So can we continue? If we can continue, type we can continue. If we can continue, type we can continue. I want you guys to have knowledge of what catalyst is, so that we'll not have any issue as we move on. I'll still teach you people energetics, so you people should also be considering me. It's not easy for me to be teaching like this. It's not easy, because you people can also join my tutorial. I know some of you guys are my students already. Some of you guys are students that belong to my tutorial already. If you want to join my tutorial, we teach chemistry, physics, biology, and use of English in my tutorial for Jamb students, just science students. If you want to join the Jamb tutorial, send me a message. This is my WhatsApp number, right? 07081179179. Send me a WhatsApp message and tell me you want to join my tutorial. It is not free. One subject is 1,000 naira, 2 subjects is 2,000 naira, 3 subjects is 3,000 naira, and 4 subjects is 4,000 naira. Okay, transition metals. Okay, scandium and zinc. Yeah. Yes. Transition metals. We can continue. So let's continue. Right. So now, there is something I want us to talk about. Right. There's something I want us to talk about, and that thing is quite important because Jamb sets question on it. It is not something difficult. It is what we call the equilibrium constant. The equilibrium constant, right? The equilibrium constant. It's not something difficult, but Jamb sets question on equilibrium constant. And one thing I want you guys to know is that equilibrium constant is temperature dependent. Jamb likes asking this thing. Equilibrium constant is temperature dependent. It is the temperature that will determine, or temperature can alter the equilibrium constant of a particular reaction. So everybody, I want you all to type equilibrium constant is temperature dependent. Everybody type equilibrium constant is temperature dependent. Everybody type equilibrium constant is temperature dependent. Jamb likes asking this question. Jamb will be like, which of the following factors can alter the equilibrium constant of a chemical reaction? That's how Jamb will ask. They will write pressure, they will write concentration, they will write temperature, they can write another thing. But you should know that your answer is what? Temperature. You should know that your answer is temperature. Why? Because equilibrium constant is what? Temperature dependent, right? So all of these things are things you guys should know. All of these things are things you guys should know, right? So now, I want to tell you guys how equilibrium constant is always gotten. I want to explain to you guys how equilibrium constant is always... Do you want me to explain step by step of how equilibrium constant is gotten, or do you want me to give you just the formula? Should I give you the formula, or I should explain step by step on how it is gotten? Because Jamb cannot ask you step by step on how it is gotten. It is just the formula that you need for your Jamb exam. Just the formula. So I want to let you guys, I want to hear from you guys. Okay, so from the everybody, just about two people, I think three people, yeah. Three people said I should explain step by step why a lot of people said I should go straight to the formula. Because the fact is that Jamb will not ask you for the step by step. You just have to go straight to the formula. But because of the little people that are asking, I'll just give a little explanation. But I will not even go deep normally. Equilibrium constant. The formula is always gotten from, we actually use our normal content, like our KF, like content or rate of reaction. The equilibrium constant is gotten from the rate of reaction. If you have done your energetics, you should know what rate of reaction is, right? We usually calculate rate of reaction for the forward reaction and for also the backward reaction. And you know that if you want to derive equilibrium constant, we usually use the law of mass action, right? And law of mass action just tells us that the rate of a chemical reaction is proportional. Rate of a chemical reaction is proportional, right? Proportional to the product of the concentration of the reacting substances. You understand? That's just it. So let me just give you guys the formula. The formula that you need to know in order to solve questions on. So let me just give you guys the formula straight so you won't have to waste time. So before I give you the formula, I would love to give you like will I say an equation, for example. Yes, that's the thing I will say. I'll give you guys an equation, right? So let me form an equation. Let me say small letter A. Let's say this is gaseous plus small letter B. I'm going to explain on. I just want to use all of these parameters to give you guys the this thing, the formula. I want to use this form to give you guys the formula, right? People should be looking at me. See here, in this equation I just wrote, these small letters, this A, B, C, this small letter A, B, C, and D, they are the number of moles. They are the number of moles. Just like if you say number of moles, now if you have something like 2CO2, right? These two, it tells us that 2 moles of CO2, right? 2 moles of CO2. So this small letter A, B, C, all these ones, they are moles, right? I'm just using them as an example so I can give you guys the formula, right? So now, equilibrium constant, right? Equilibrium constant can be in form of KEQ. We can write it as KEQ. This is the equilibrium constant of the equation. Or it can be in Kc. If we say it's Kc, that means we are talking about equilibrium constant when the concentration is in moles per dm cube. Do you people know the formula for concentration? Do you know the formula for concentration? We say concentration. What am I writing, Seth? Concentration, which is in moles per dm cube. Mole over volume. Do you people know this formula? Formula for concentration. If you don't know it now. Concentration, mole over volume. Mole divided by volume. So this will give us the unit of concentration to be moles per dm cube. This thing is very, very rampant in solubility. Solubility. Have you people need to be studying, have you people read solubility at all? You people need to know this formula, right? Mole over volume, and the unit is mole per dm cube. You know that the unit of volume is dm cube now, which is liter, and this is over, so that's why it's having per. So mole per dm cube, that is the unit of concentration, right? Concentration in moles per dm cube, right? So now, if you want to talk about the equilibrium constant in relation to concentration, you can make your KEQ to be equal to your KC. Sometimes you can make it to be KP, right? If it is in KP, then that means you are talking about pressure. You're talking about pressure, like partial pressure of a gas. Partial pressure of a gas. You understand? But most times, let me also write it in KP. If it is in KP, that means you are talking about equilibrium constant, talking about partial pressure of gas. Let me write it out. Partial pressure of gas. In Jamb, they won't always give you KP sometimes, but they will always give you KC. KC talks about concentration. I like writing concentration. Conc in mole per dm cube, right? Moles per dm cube, right? So now, the formula for our concentration. This thing is not like you'll be solving. You should not be afraid, though. It's not like you'll be solving plenty things. So you should not be afraid. It's just a small formula, right? It's just a small formula. So our equilibrium constant, which talks about in concentration, in relation to this equation, you are going to be having your product, concentration of your product over concentration of your reactant. You understand? Concentration of your product over concentration of your reactant, right? Here, our product is C and D. Product is C and D now. Product is C and D. So if you want to write concentration in chemistry, instead of writing concentration, you can just write this type of bracket. You see that this bracket is different from this bracket. This bracket is different from this bracket. So if you see this kind of bracket in chemistry, just know that they are talking about concentration, right? So capital letter C, you now raise it to the power of C. This C is small letter c. This is the moles. This one represents the moles. This small c represents the moles. And this is one of the products now. Then you make it multiply by the second product, which is our D. It can be normal, this thing, like normal molecules or normal atoms now. You raise it to the power of D, right? Which is the number of moles, right? Over, remember that it's product over reactants, like products. Let me know that equal to products. That's concentration of products in moles per dm cube over concentration of reactants, right? In moles per dm cube. So our reactants here is A and B now. So you have something like A, then we have something like B, or raised power of normal B. Do you understand this formula? I'm going to give you guys a question like where you guys will just deduce the you guys will just be able to deduce this thing, just the unit. You understand? Just the unit. It's not hard to just know this. Just know that concentration of products over concentration of reactants. That's how you can get your equilibrium constant, right? Don't stress yourself. Oh. It's not something really difficult like that. It's very simple. You understand? So now let me give you guys an example now. They say you should find our topic is chemical equilibrium. If they say you should find, okay, let me give you guys an example. Let's use ABA process now. That's the manufacturing of ammonia now from nitrogen gas. Nitrogen gas reacting with, like, let's say 3 moles of hydrogen gas. Wait, do you people already know how to balance chemical equation? Because I remember I said I want to make a video about it, and I've not made a video about it. Have you people read about it at all? For those of you that don't know how to, have you read about it at all? Have you people read about it at all? If you are just joining this live for the first time, the best thing to do is to subscribe to my YouTube channel, because that's the best way to support this live. And also tap on your screen, double tap on your screen to like the live. We are still at 41 likes since. Yeah, you said if you see video for 41 likes, you go watch them. Is you only that reaction that is for equilibrium? No. Many reactions can be used now. Many reactions can be used though. Any reaction that is in equilibrium, any reaction that is reversible, that is in equilibrium, can be used. Any reaction that is in equilibrium or that is reversible can be used too. It's not only that one. So now, if you want to get the equilibrium constant of this thing, it's very simple. You can just say our Kc is going to be the concentration. What's the concentration of our products? Remember, it's concentration of product over concentration of reactants now. Abina, concentration of product over concentration of reactants. Our product is what? What is our product? What is our product in this reaction? What is our product in this reaction? So if you see this question in your Jamb exam, they will just give you an equation. You just say, what is the equilibrium constant? Or equilibrium constant in this equation is, what is our product in this reaction? If we do this, so I'm going to give you guys work to do. Our product is ammonia gas, NH3. So you write NH3. That's concentration of NH3 in moles per dm cube. Then remember, it has 2 moles. 2 moles, right? 2 moles. So you need to put power of 2, right? All over what is the reactant? What are the reactants? It has 2 reactants, right? So the first reactant is nitrogen gas. That one, it only has 1 mole, so you not write anything. Then the second reactant is what? Hydrogen gas too. But that one has how many moles? 3 moles. So you need to raise it to power of 3. So in short, this is just the equilibrium constant. You can see. Remember that this equilibrium constant, it actually has. Do you know that you can equilibrium constant, the unit of equilibrium constant differ. The unit of equilibrium constant changes according to, according to the level of the reaction. Yes. My phone is so hot. 17% and so hot. That's why the battery rate of my phone needs to go down quickly. Oh long God. It's really God that will help me out, because this teaching that I'm doing here. So, what did I tell you people about the unit of concentration earlier? What did I say the unit of concentration is? What did I tell you people that the unit of concentration is? What did I tell you people that the unit of concentration is? What did I tell you people that the unit of concentration is? Moles per dm cube, right? So now, you can see that this ammonia, concentration of ammonia, right? This thing is encapsulating or is covering this ammonia, concentration of ammonia. What I want to do now is just I want to try to get the units of this equilibrium constant in this reaction. Remember, I told you that units of equilibrium constants can alter depending on the reaction, right? It can alter depending on the reaction. You understand? So for this particular reaction, I want to get the unit of this equilibrium constant. You understand me? So now remember, the unit of our normal concentration is moles per dm cube, right? So let's say moles per dm cube for the upper part. Moles per dm cube, I'll put it in brackets. Remember, this has a power of 2, so I can just put 2 up, right? Also remember, for this one, the lower side, which is we have nitrogen and hydrogen gas at the lower side. Hope you get me. You have nitrogen and hydrogen at the lower side, right? So both of them, you know that this thing. Wow, Ola Daniel, you didn't receive any notifications when I went live. Wow, are you for real? Are you for real that you didn't receive any notifications? Are you for real? Wow. You say YouTube too is now doing like TikTok me. So now you know that unit of concentration here. Unit of concentration here is what? Moles per dm cube. Also, unit of concentration here is moles per dm cube. Now, I want to ask you guys a simple question now. You know that here, the number of moles of ammonia is 2 now. Number of moles of ammonia is 2. That's why I put power of 2. Is it that you didn't subscribe, or is it that you didn't turn your notification bell on? Because I know that YouTube used to notify everybody. That was one of the reasons why I'm moving to YouTube to teach. So now, what amount of moles of nitrogen gas do we have? You see, this has a power. This concentration, it has a power. Do you know that it has a power? What is the power? The power of this concentration of hydrogen gas is 3, because it's 3 moles. This one, what is the power? Nitrogen gas, what is the power? Hey, 9%, my phone is hot. Will I be able to finish this class like this? The power is 1, right? The power is 1. So the power is 1 here, right? So now I want us to use the normal law of indices. We know that the unit of concentration normally is moles per dm cube now. So let us write our moles per dm cube. Right? Moles per dm cube, right? So you know we need to put a power to it. It needs to have a power. Here it has a power 3, and here it has a power 1. According to the law of indices, if we want to multiply the same bases, like these bases are the same, and what is the base? The same basis that they have. This moles per dm cube is the same base that they have. You know what we are doing is in terms of bases now. This is why people need to understand mathematics. So now, if you have a base, the same base, and you have different power, and you want to multiply them, what will happen to the powers? Will you add the powers, or will you subtract the powers from normal law of indices? Because both of them, they have the same unit, right? Moles per dm cube. So that's why I've already written moles per dm cube. So now you can see the base. You can see the powers. The powers are different, 1 and 3. And the sign that is between them is multiplication. I believe you know that it's multiplication that is between them. So normal law of indices, if the two things have the same base, you need to add the power. So 1 plus 3 will give us 4. Right? That will give us 4, right? So now, I want us to do this thing small. till we get our answer, right? So now we need to multiply the things that are this things. If I were the one that wants to do this thing, all these steps that I'm going through, I will not go through it though. I will not go through all these things. If I were the one to do this thing myself, I will not even be writing all this thing. I will just write the units straight because there is no wahala. But I'm trying to explain so that you guys can understand. You understand? So let us open these brackets. Let us open, or without even opening the brackets, without opening the brackets, we can use the law of indices again without opening these brackets. Okay, I want to ask you guys a question. Should we use the law of, this is division now. We are dividing these two things. You can see they are the same basis. The only difference is just in their power. The only difference is in their power. So we can use the subtraction law of indices. We can use the subtraction law of indices for this. But I want to ask you guys a question. Do you want us to use subtraction of law of indices, which will be faster for us? Or do you want us to do it small? I want to let you guys, I'm asking from you guys. Do you want us to do it small that we'll first open the brackets? We open this bracket with 2, we open this bracket with 4, which is going to be very long and it's going to be stressed. Or let's also use the subtraction law, sharp. Because I believe you people are science students. So you people should know the indices very well. You people are science students, you people are supposed to know indices. Somebody says subtraction law, and that person says yes, and that person says small. Which one are we going to pick? Okay, I think a lot of people are going for subtraction law. Let's do subtraction law. Science students. You people are science students. You people are not supposed to be saying we should do small now. Because this is mathematics, simple mathematics. You people should know these things. This is SS1. Subtraction law is SS1. So let's do subtraction law of indices. Subtraction law of indices, you can see that there is the division. Anytime you see division, you just know that you want to subtract, right? And you can see that the bases are the same. So you just have to write one base out, which is mole per dm cube, right? Moles per dm cube now. So you can put it inside your brackets now, right? So subtraction law, 2 minus 4. 2 minus 4 is what? 2 minus 4 will give you minus 2. Normal now. 2 minus 4 will give you minus 2, right? 2 minus 4 will give you minus 2. So like that. Let's just use this minus 2 to open our brackets. So if you have something like, if minus 2, I'm on 10%. If minus 2 multiplies our mole, you are going to have something like mole raised power minus 2, right? You see, per mole squared, then minus 2 times minus 3. Minus 2 times minus 3 will give us what? Minus 2 times minus 3 will give us what? Minus 2 times minus 3 will give us what? I'm asking from you guys. So minus 2 times minus 3 will give us what? Plus 6. Yeah. So you now have something per mole squared dm raised power of 6. So this is the unit. This is the unit of this particular equilibrium constant. This is the unit. You see that I derived the unit from the formulae, right? Sometimes they might not ask you to derive the unit. They can just ask you for just this, just to write this formulae out, just this. Sometimes they just want to see this alone, but sometimes they'll tell you to find this unit. You know that if you write this formulae out now, you need to write the unit in front to show that this is it. This is the unit now. This is the unit of whatever you get. So this is how we get the unit. So should I give you guys an example? Should I give you guys is the example considered? I'll call it a classwork. Wow, 6%. Okay, so let me give you guys a classwork. Let me look for a simple one because I don't want stress. Hey, Okay, so let me give you guys one. Let me use ethanoic acid. If ethanoic acid is breaking down, ethanoic acid aqueous. It's breaking down to give us CH3 COO minus aqueous plus hydrogen ion. Yup. So don't worry, man. I'm with power bank. It's just that my phone is just hot. That's why. So this is the classwork. People should write the formula. Write the formula and also give me the this thing. The units. Write the formula out and also give me the units. Write the formula out and also give me the units. And we go. The people that want to do it will take time because for you to be typing and using those brackets and putting everything inside. Shall I do it? I want to see it, sha. If you are watching this video anytime, if it's the recording you are watching or you are live here with me, I want you to do your own and type your answer in the comments. Type your answer in the comments. First, send the formula and then send the units also. I believe you guys are with your book. Yes, it does not have any mole. Yeah, it's already balanced like that. It does not have any mole. Yeah, it's balanced. It has mole now. One mole. One mole. So that's one mole. So I'm waiting for you guys. So that's one moles. There's still one important part though. There's still one important part that I need to explain because that's the main thing that I usually ask questions on a lot. I think I need to explain that part because I'm also tired. I need to sleep as well. But I feel like that's one of the main reasons why I came to teach you people this topic. Because of that particular part. So while you guys are doing whatever you are doing, let me just go to the part. Okay, some people are already typing their answers. So equilibrium constant is CH3COO. Remember that this thing is product over reactant. The other person. CO minus, okay. Then H all over CH3. Okay, this makes sense. Correct. This shows that you are following me. So what is supposed to be the unit? It shows that you are following me. What's supposed to be your unit? My back. So while you are doing it, let me quickly do it too. So our case, we all know that our case normally is supposed to be product over reactants now. So we have something like concentration of the products. Our product is CH3COO minus, normal now. And then our H plus, right? All over. What's our product? Ethanoic acid. So concentration of CH3 COOH. Right? So let's quickly get our units, right? We know that for for these two now, this is mole per dm cube, also mole per dm cube. Abi now, this mole per dm cube and also mole per dm cube. You know that this one has 1, this one too has 1. If you use your normal this thing, your normal indices law, you are supposed to have something like moles per dm cube, mole per dm cube. Then you can put 2 now. You know that is 1 now. 1 plus 1 is 2 now, right? All over. This is the unit of this is mole per dm cube now. Mole per dm cube now. So if you put this in brackets, you know that it's just raised to power 1. I'm making this thing very simple for you guys. It's just raised to power 1. Abi now, just raised to power 1, right? So you can see that the bases are the same. The bases are the same, right? The bases are the same. So you can use subtraction law of indices. If you want to use subtraction law of indices, you just pick one base and you subtract the powers, right? So the base is what? Mole per dm cube. Moles per dm cube. Then if you subtract the power, 2 minus 1, what do you get? 1. So if you open this bracket with 1, what will you have as your final answer? You have your final answer to be mole per dm cube. So the unit of this is mole per dm cube. Very simple. Do you understand? So where do you see minus 3? Minus 3. Where is this person asking? Maybe it's somewhere very, very far. Okay. I think the person was asking from where there were minus 3. Okay. It's from this place now. Yes, now moles per dm cube. Moles per dm cube. Per, this per is the minus. You can decide to write this as, or you can decide to write mole per dm cube like this, or people have forgotten your indices. Mole per dm cube. It's the same thing now. This slash sign or over sign is just what I'm representing with my minus. It's just law of indices now. 1 over m is same thing as m raised to power minus 1. This is just law of indices now. It's just simple law of indices. People should go and do your mathematics well before you come here, because science students supposed to be maths. Supposed to be maths. My phone is 8% and it's somehow doing like the thing wants to die. And I've not really spoken about the real deal of the day. The main reason I came to this place, because I want you guys to know that particular thing, because Jamb is to ask. So now let's talk about, let's just go to it. So I believe you guys understand this now. So let's just go to the main thing. The main thing is what we call the Chatelier principle, right? The Chatelier principle. This is the main reason I'm here. This is the main reason I'm here. The main reason I'm here is for Chatelier principle. Is there anybody on this live code that knows or that can state Chatelier principle? Is there anybody on this live code that can state the Chatelier principle? Is there anybody that can state the Chatelier principle? The Chatelier is actually a Frenchman. He's a Frenchman, and let me tell you. Let me tell you his principle. The Chatelier principle states that if any condition, people are saying you don't know, that's why I'm stating this now. If any of the conditions of a system, right? If any of the conditions of a system in equilibrium. So Chatelier principle talks about a system in equilibrium, right? You know, we've always been talking about equilibrium now, chemical equilibrium. So Chatelier principle states that if any of the conditions of a system in equilibrium is altered, or you can say is changed, right? Is altered. let me see, is altered. You know that altered means change now. Let me put this in brackets. Right? If any of the conditions of a system in equilibrium is altered or changed, right, the system will adjust itself. The system, hope you guys are seeing, the system will adjust itself. Will adjust itself. Will adjust itself so as, or you can say, will adjust itself in order to annul the effects of the change. When you say annul, that means like to neutralize the effects of the change. You can, this annul, you can decide to represent it with, let's say, neutralize. That's what Chatelier said. Chatelier said that if any of the condition of a system in equilibrium is altered, right? A system that is in equilibrium. Okay, let me give you the conditions that can be altered. The temperature can be altered. The concentration can be altered. Even the pressure can be altered. Right? These three main things, they are the most things that can be altered to have an effect on the equilibrium position. Right? Some people will say catalyst, but the simple thing is that catalyst does not affect, everybody type catalyst does not affect equilibrium position. Does not affect equilibrium position. So everybody type a catalyst doesn't, or a catalyst does not affect equilibrium position. A catalyst does not affect equilibrium position of a reaction. The main things that affect equilibrium position of a reaction is temperature, concentration, and pressure. Remember, I told you guys that what a catalyst will do is that a catalyst alters the rate of a chemical reaction. So what a catalyst does is that it changes, or it have effects on the rate of a chemical reaction, on the rate. That's the speed. It either slows the reaction down, or it speeds the reaction up. That's the work of a catalyst. It does not affect the equilibrium position of the system or of a reaction. Hope you guys are following me. So these three main factors are the ones that affect the equilibrium position of a reaction. And when they affect the equilibrium position of a reaction, according to Chatelier, the system will adjust itself in order to annul, or in order to neutralize the change. If, let me give you an example now. If the temperature go and increase now, let's say the equilibrium position is at this side now, and the temperature just go and increase anyhow, you know that as temperature increase now, the equilibrium position will change. You understand? So the system will need to adjust itself. It will need to adjust itself in order to come back to equilibrium again. The system will need to adjust itself in order to come to equilibrium again. That is what Chatelier said. Chatelier said that if any of the conditions of a system in equilibrium is altered, the system will adjust itself in order to annul, or in order to neutralize the effect of the change. Right? So they always want to be in equilibrium. Right? My phone is at 8%, and my phone is damn hot right now. This thing will be affecting my battery health as I'm charging, as I'm using the phone. It is well, oh. Big money that somebody used to buy phones. Somebody's using the phone anyhow. It is well, oh. So that's least at least principle, right? So now I'm going to be giving you guys how the system annul changes. How the system annul changes when there's change in temperature, when there's change in concentration, and when there's change in pressure, right? Before then, I want to tell you guys about exothermic reaction. People need to know exothermic reaction. If you are joining for the first time or any time, if you are watching this thing, ensure that you like this video. Tap on your screen, double tap on your screen. Exothermic reaction and endothermic reaction. Alright? I want you guys to know the differences and the meanings of these two terms. Right? An exothermic reaction is a type of reaction where heat is released to the environment. It is released. That's just it. It is released to the environment. And for an exothermic reaction, it is absorbed. You see the difference? An exothermic reaction, it is released into the environment, and for an endothermic reaction, it is absorbed. So there's another thing you need to know. For an exothermic reaction, the delta H, which we call enthalpy, or you can say its change. The enthalpy is always negative for an exothermic reaction. Negative. For an exothermic reaction, enthalpy is always negative. Enthalpy is always negative, right? For an exothermic reaction. Now, for an endothermic reaction, where heat is absorbed, it is absorbed in an endothermic reaction. Our enthalpy, which is our delta H, which is our heat change, is what? Positive. This is something you people need to know. This is why I said I want to teach you guys energetics, because all of these things are things you need to learn under energetics, right? All of these things are things you need to learn under energetics, right? Hope you guys are following me. So now, for an exothermic reaction, heat is released into the environment, and delta H is negative, right? Endothermic reaction, heat is absorbed, and delta H is positive. Delta H is its change, right? It's changed from the product to the reactant. I hope you people also know the graph, sha. Do you people know the graph? Do you people know? Can you people differentiate the graph? If they give you the graph in your Jamb exam, can you know that this is endothermic and this is exothermic? If you people have, like, if they give you the graph in your Jamb exam, will you be able to know if this is exothermic and endothermic reaction? My people are saying yes. Wow, so people are saying no. Okay, let me just give you how to the graph. Let's say this is the energy now. Let's say this energy, this side is energy, the horizontal side, and this is like the time or so. For an exothermic reaction, you have the energy coming from the upper part, then it goes down. This is for an exothermic reaction. You can see. For an exothermic reaction, you can see the activation energy, right? This is for an exothermic reaction, right? You can see it's starting from a very high energy. That's an exothermic reaction, and it releases heat. It releases heat into the environment, right? This is an exothermic reaction. This is how the graph will look like. You can see. Yeah. This is where you have the activated complex. This is where we call the activated complex. Activated complex. If you are asked to label this, this is what we call the activated complex, right? So For an endothermic reaction, you see, I'm already teaching you energetics small small. Even me too. You people should know that there is church tomorrow. I want to go to church. And my pastor already called me. He said I should not come late. You understand? Right? So now, for an endothermic reaction, you have something like this. You can see. You can see. You can see. For exothermic reaction, you can see that the reactant, you can see where it's starting. A lot of reactants. You can see the product plenty sharp. You can see. You see that the for this endothermic reaction, endothermic reaction, you know that in an endothermic reaction, it is absorbed, right? You can see where the graph is starting from below. Then it goes this way. You understand? See here, from this place, getting to this place is where we have our activation energy. Activation energy now. Activation energy is just like the energy that must be overcome before a reaction will have to occur. You understand? That is where this thing comes in. A catalyst. That is where a catalyst comes in. A catalyst usually it alters the this thing, the reaction pathway by lowering the activation energy. By lowering the activation energy. You understand? For example now, see here, for this endothermic reaction now, you can see that, see the activation energy go from this place to this place. See, if you now put catalyst in this reaction, in this particular reaction, catalyst can alter the reaction pathway, that the reaction will go this way, and it will just go like this. You see that the activation energy or the activation energy has been reduced. You see that the activation energy has been reduced. You see, from this long thing to this short thing. So it will just be faster. That is one of the roles of a catalyst. A catalyst changes the pathway, right? It changes the pathway or the reaction pathway. That's just that for that, sha. I'm just trying to like to go in a place I'm not supposed to go. But people should not forget that an exothermic reaction, heat is released, and for an endothermic reaction, heat is absorbed. For an exothermic reaction, delta H is negative. For an endothermic reaction, delta H is positive, right? Heat is released into the environment. I hope you guys are following me. So now, it's not easy. So now, I want us to treat a particular. Can you guys hear me now? Can you guys hear me now? Can you guys hear me now? I want us to treat a particular question where the conditions will be altered. You understand? The conditions will be altered. I want us to use about process because that's always faster. That's always faster. About process has a lot of. Let's just use about process. Two moles of ammonia and the delta G, what am I even saying? Delta H Delta H is negative, you see, minus 91 kilojoule per mole, right? Minus 91 kilojoule per mole. So now you can see this reaction. The first question I want to ask people from this reaction, the delta H of this reaction is minus 91 kilojoule per mole. The first question is that what type of a reaction is this? Is this an endothermic reaction or an exothermic reaction? That's the first question I want to ask you people. This formation of ammonia, is it an endothermic reaction or an exothermic reaction? Is it an endothermic reaction or an exothermic reaction? Okay. Good. It is an exothermic reaction. So I want to ask you guys, why is it an exothermic reaction? Why is it an exothermic reaction? Why? People should tell me why. Why is it an exothermic reaction? Why is it an exothermic reaction? Here we go. Why is it an endothermic reaction? Or why is it an exothermic reaction? Okay, it is an exothermic reaction because it has a negative enthalpy. Because delta H is negative, so that makes it an exothermic reaction, right? That makes it an exothermic reaction, right? So now let us talk about change in pressure. Change in pressure, right? Change in pressure. Change in pressure. If the pressure experiences a change, if pressure for this particular reaction now, I want you to explain the change in pressure, change in temperature, and change in concentration, how it affects a reaction, right? So now, for this particular reaction, do people know the relationship between pressure and volume? Which law tells us the relationship between pressure and volume? Which gas law tells us the relationship between pressure and volume? Which gas law tells us the relationship between pressure and volume? Boyle's law. Boyle's law tells us the relationship between pressure and volume. And it tells us that what? It tells us that they are inversely proportional. It tells us that pressure is inversely proportional to volume, right? Was that not what Boyle's law said? Was that not what Boyle's law said? Boyle's law told us that pressure is inversely proportional to volume. Was that not what Robert Boyle told us? So that means that as the pressure increases, the volume will decrease, right? As the pressure increases, the volume will what? Decrease. And as the volume decreases, the pressure will also increase. Are you guys following me? Are you guys following me? Are you people getting what I'm explaining? Are you people getting what I'm explaining? Okay, so let me continue. So that means if the pressure increases, the volume must what? Must decrease. If the pressure increases, the volume must decrease to neutralize the change. Remember that what Le Chatelier's principle always does is to always neutralize the change when there is a change in the system. You understand? If there's a change in the system, Le Chatelier's principle, what it does, it tells us that the system will what? Neutralize the change. So if pressure increases, volume must decrease to neutralize the change, right? And that means that if pressure decrease, volume must what? Increase to neutralize the change. Do we get that logic now? If pressure decrease, volume must increase to neutralize the change. So in this reaction now, the first thing you need to know is that you know that this is the forward reaction, right? This is the forward reaction and this is the backward reaction. For this now, what are the number of moles? What is the total number of moles that we have at the reactant side going towards the forward reaction? We have 1 mole here and 3 moles here, right? That gives us how many moles in total? 4 moles. Right? 4 moles. 4 moles in total. You're not seeing clearly, okay? Can you guys see clearly? 4 moles in total on the reactant side. And 2 moles at the product side, right? 2 moles at the product side. Right? So this is the mole. And also remember that as mole increases, volume also increases. As mole increases, volume also increases. That's one of the things that Avogadro tells us. Avogadro tells us the relationship between mole and volume, right? So, as the mole increases, the volume will also increase. So, that means that this side that has 2 moles has lesser, let me see. This one that has 2 moles has what? Lesser volume. Lesser volume. Right? And this side that has 4 moles, we have more volume. Do we concur with that? Following Avogadro's law. You should know that all of these are gases. And gases follow Avogadro's rule now. Normal. So now, for this particular reaction now, right? If I want to talk about pressure now, if there is an increase in pressure, for this reaction, if there is an increase in pressure, the reaction will favor the side. You know that, remember I told you guys that if pressure increase, what must happen to neutralize the change? Volume must decrease, right? I told people that if pressure increase, what must happen to neutralize the change is a decrease in volume, right? So if there is an increase in pressure, the reaction will favor the side with lesser volume, or I can just use mole. Do you understand? If there is an increase in pressure for this particular reaction or for any type of reaction, if there is an increase in pressure, the reaction will favor the side with the lesser volume and vice versa. When I say vice versa, it means that if there is a decrease in pressure, if there's a decrease, you should not forget this. This thing is very important too. I would love you to always come back to watch this particular video because I will be dropping the recording. Because this thing is important. Jamb used to set question on it and this thing is somehow confusing. If there is a decrease in pressure, the reaction will favor the side with more moles, right? Or let's say more volumes, right? You understand? Hope you guys are following me. So now, for this particular reaction, for this Haber process now, where nitrogen gas is reacting with hydrogen gas to give us 2 moles of ammonia, if there is an increase in pressure for this particular reaction, which direction will it favor? Will it favor the forward reaction or the backward reaction? If there is an increase in pressure, will it favor the forward reaction or the backward reaction? From this explanation that I just made, that if there's an increase in pressure, it will favor the side with lesser mole or lesser volume. And here at the reactant side, we have 4 volume or 4 moles, and at the product side, we have 2 moles or 2 volume. Correct. It will favor the forward reaction because I said that increase in pressure will favor the side with lesser volume. And in this particular reaction, the product side, which is ammonia gas, has 2 moles, and that is lesser volume. So it will favor the forward reaction. It will favor the forward reaction. The forward reaction. The forward reaction is the reaction that has small volume or small mole, right? As you can see, small mole. I say that if there's an increase in pressure, it will favor the side with lesser volume or with smaller volume or smaller moles, right? Smaller mole. And inside 2 and 4, which one is smaller? Inside 2 and 4, which one is smaller? 2 is smaller. So it will definitely favor this direction, right? It will definitely favor this direction. Do you guys understand? Do you guys understand? People should calm down. I'm going to give people classwork. People should calm down. Let me explain what I want to explain. Finish. I'm still explaining. Let me explain what I want to explain. This thing will favor the forward reaction, right? It will favor the forward reaction. So now, for the second thing, a decrease in pressure. If there is a decrease in pressure, if the pressure decreases, remember I told you that if the pressure decreases, it will favor the side with what? With more moles. If the pressure decreases, it will favor the side with more moles. So for this reaction, if the pressure decreases, which side will it favor? Will it favor the forward reaction like this, or will it favor the backward reaction? For this particular reaction, if there is a decrease in pressure, will it favor the forward reaction or the backward reaction? Okay, that was good. People are getting it. So it will favor the backward reaction. Why? Because the backward reaction has more moles, or let's say has more volume than the forward reaction. So this is the backward reaction. It will favor the backward reaction, right? So that is that for pressure. So now, let me quickly give you guys one simple one. So let me give you guys one simple question. Let's say this N2O. Let's say N2O4, yeah. Reacting reversibly to form 2NO2. For this reaction, I want to ask you people a question on this reaction. If there is an increase in pressure, for this reaction, if there is an increase in pressure, or if the pressure is increased, will it favor the forward reaction or the backward reaction? For this reaction, if I increase the pressure, will it favor the forward reaction or the backward reaction? Correct. People are correct. To favor the backward reaction. If there's an increase in pressure, it will favor the backward reaction. Favors the backward reaction. I'm going to write my backward reaction like this. It favors the backward reaction. Right? If there's an increase in pressure for this particular question, or for this particular equation, it will favor the backward reaction. Why? See, at this place, we only have 1 mole, reactant side. Product side, we have 2 moles, right? And I said that if there's an increase in pressure, it will always favor the side with lesser mole. And this side has lesser mole, 1 mole, and this one is 2. Which one is greater? This one is greater, so this one is lesser mole. So backward reaction will be favored if there's an increase in pressure. What if there is an What if there's a decrease in pressure? What if there's a decrease in pressure? Where will it favor? What if there's a decrease in pressure? Where will it favor? It will favors the what? Forward reaction. Right? Forward reaction. It will favor the forward reaction, right? Do you people understand? Do you people understand this thing? So I don't think if people are giving any question that is about pressure, or that they say that the thing is having issues with pressure, or the pressure changes, I think you people should be able to know now. You should be able to know which side of the reaction will be favored. Right? You should be able to know the side of the reaction that will be favored now. So now let us move to the second let me say the second thing that can change. The second thing that can change, which is wait to I'm on mute. Oh, sorry. So the next thing is concentration, right? Right? This concentration is also simple. Wait, can you hear me now? Can you hear me now, please? Oh, can you hear me now? Can you hear me now? Um, okay. I believe you guys can hear me now. So for concentration, I believe you guys know what concentration is. I've explained earlier that concentration is just normal formula now. Mole over volume bar. Good. So now, just for this one, just normally for our normal equations, you know that concentration now, if there's an increase in concentration, if there is an increase in concentration, if there is an increase in concentration, the reaction must favor the side that is less concentrated. If there is an increase in concentration, the reaction must favor the side that is less concentrated. Right? For example now, for this particular Haber process, if there is an increase in the concentration of nitrogen and hydrogen gas, the reaction will automatically favor the forward reaction. Right? The reaction will favor the forward reaction. If there is an increase in the concentration of the reactant, the reaction will what? Favor the forward reaction. Because if there's an increase in the concentration of reaction, then the concentration has to be shifted to the product side. You know that's what this Chatelier said now. He said that if something increases, we must always do another thing that will nullify it, or another thing that will neutralize the change. So if concentration increases at the reactant side, then it must favor the product side. You understand? So if there's an increase at the reactant side in the concentration, then the product side with lesser concentration must be favored. Hope you guys are following me. So now, Opposites, or let me say going through the other way, if there is a reduction or if there is a decrease, if there is a decrease, let's say if there's a decrease in the concentration, you'll be given in the question actually. You'll be given in the question, they will tell you that if the concentration of the reactant is increased, what part of the reaction will be favored? So if the concentration of the reactant is increased, the forward reaction will be favored. You understand? But if the concentration of the reaction is of the reactant is decreased, if the concentration of the reactant is decreased, then the backward reaction will be favored. If the concentration of the reaction of the reactant, if the concentration of the reactant is decreased, the concentration of the reactant is decreased, the backward reaction will be favored. Most times for concentration, we use the number of moles to know, right? Just like using normal volume now, just like using our normal volume, but that's what we use for concentration as well. Hope you get me. So for this one now, for the concentration, if you increase the concentration, it will automatically favor the side with lesser mole. You understand me? It will automatically favor the side with lesser mole. Hope you guys are following me. So now, if the concentration is reduced, or if the concentration is reduced, it will favor the side with more moles. This thing is just like opposite. This thing is just like opposite, right? This thing is just like opposite, right? Okay. Let me explain better. This thing is just like opposite. If, see now here, we have 4 moles of nitrogen and hydrogen gas, right? That's 4. But and here we have 2. If there is an increase in concentration, it will favor the side with lesser concentration. This side has lesser concentration. If you want to know the concentration, just check the moles now. Just check the moles. Know that formula for concentration is what? Mole over volume. Mole over volume. So the side with more moles is the side with more concentration. You understand me? So here now, if the concentration is increased, you see this one has 4 and this one has 2. The reaction will have to favor the side that has smaller concentration. So if the concentration is increased for this reaction, it will favor the forward reaction, which is towards the product side, right? But if the concentration is reduced, or if the concentration is reduced, or if concentration decreases, it will favor the side with more moles. It will favor the side with more moles. It's just like vice versa. So if the concentration is reduced, it will favor the side with more moles. That's the opposite reaction. That's the reverse reaction, right? I believe you guys understand. So now the third thing is temperature. Yeah. It's same as pressure. The third thing is temperature. The thing is that for temperature, it actually depends if the reaction is either exothermic or endothermic. Remember, I told you people that when delta H is negative, that means it's exothermic, right? And when delta H is positive, that means it is endothermic. Abi? Negative means exothermic and positive means endothermic, right? That's what I told you people, right? So now, I think I need to give you two different ones. Let me make this in a new place so you will not be confused. Let's do for exothermic first, because it's only temperature that is like that. You know that exothermic deals with temperature now. Exothermic reaction. For example, now that ABA process is an example of exothermic reaction because it is being released, right? It is being released to the environment, right? So, should I write? Let me just use it again, right? Let me just use it again. Or for an exothermic reaction, Okay, I'm coming on. Should I just use the same equation again? I think I have to use the same equation again. But I don't really think I need the equation for this. It's just something you can use math to explain, sure. This is a gas now. Plus 3 moles of hydrogen gas to give us 2 moles of ammonia. And we know that the delta G, delta H, delta H is negative. I think that's negative. Is negative what self? Delta H of ammonia of ABA process is negative 91 kilojoule per mole. Negative 91 kilojoule per mole. Right? So let's just do this thing as simple as possible. You understand? See, this is an exothermic reaction. This is an example of an exothermic reaction, right? For an exothermic reaction, don't forget that for an exothermic reaction, heat is being released. Let me try to draw something like fire, sha. I don't know how to draw fire, but I'm just giving an example. Is this fire? Does this look like fire? For an exothermic reaction, heat is being released to the environment, right? So that means that it already has a very, very high temperature. This particular reaction already has a very high temperature, right? So if there is an increase in temperature, why am I writing pressure? If there's an increase in temperature, see, I'm drawing a ghost. For an exothermic reaction, if there is an increase in temperature, remember that an exothermic reaction is already hot because it's releasing heat. It's already hot, it's releasing heat. So if there's another increase in temperature again, if you have to bring that reaction back to equilibrium, what will you do? It will have to favor the backward reaction. An increase in temperature favors mosquito. Yeah. Favors backward reaction. All of these things are things you guys need to note. So for an exothermic reaction, increase in temperature will favor the backward reaction because the forward reaction is already hot. The forward reaction is already emitting heat. So why are you increasing the temperature again? If you increase the temperature, the best way to bring the temperature back to normal is to reverse the process. You understand? It's to reverse the process. So now, a decrease in temperature, if the temperature is reduced or if the temperature is decreased, for an exothermic reaction, it favors the forward reaction. Right? Hope people are following me. That is for an exothermic reaction. So now I want to ask you a question. So for this reaction now, that the delta H or the enthalpy is minus 91 kilojoule per mole. Which part of the reaction will be favored if the temperature is decreased? How would you know the nature of temperature? You will know it. You will know that it is exothermic or endothermic from the enthalpy now. From the enthalpy now, that's the heat change. If it is negative, you know that it is exothermic. If it is positive, you know that it's endothermic. If it is negative, you know that it's exo. If it is positive, you know that it's endo. That's how you know. So in the question, they now tell you that the temperature. They now tell you in the question that increase in temperature of this particular reaction will favor what part? All you just need to know that increase in temperature, since this thing is an exothermic reaction, it will favor the backward reaction. Because for an exothermic reaction, the backward reaction is always favored when the temperature is increased. Right? You understand what I'm saying now? We consider the mole for volume, for like pressure and concentration, but not for temperature. For temperature, you don't consider the moles. You consider the value of the enthalpy. For temperature, you consider the value of the enthalpy. So now, if there is a decrease in temperature for an exothermic reaction, it will favor the forward reaction, because normally the forward reaction is already hot, it's already emitting it. So if you decrease the temperature, you have to go forward again. That means you have to go in a direction that emits it, so that the reaction can come back to its normal position again. Hope you understand me. So for an exothermic reaction, if the temperature is reduced, it will favor the forward reaction, while if the temperature is increased, it will favor the backward reaction. Wow, some people are already complaining of data. Okay, this is just the last part. Let me just the last part. So now, for an endothermic reaction, it's just reverse. For an endothermic reaction, it's just reverse. It's just reverse. For an endothermic reaction, we know that our delta H is positive now. For an endothermic reaction, so that means for an endothermic reaction, if the temperature, if you have an increase in temperature, remember that an endothermic reaction is a reaction that absorbs heat, right? Most decomposition reactions are endothermic reactions, right? The ones that absorbs heat, right? So if the temperature is increased, what will happen? It will favor the forward reaction, because it needs itself go to continue the reaction, the forward reaction. Right? So an increase in temperature will favor the forward reaction for an endothermic reaction, and a decrease in temperature will favor the backward reaction for an endothermic reaction. An endothermic reaction, somebody is asking, how about pressure and concentration? For pressure and concentration, nothing concern endothermic or exothermic. If it is either exothermic or it is either endothermic, it does not concern them. You can only use number of moles. If it is endothermic or it's endothermic, it does not concern you. You just use your number of moles normally. You understand? If the pressure is increased, it will favor the side with lesser moles. If the pressure is reduced, it will favor the side with more moles. And the same goes for concentration as well. So this is for temperature. So that is that for Lee-Chatelier's principle, right? So it's already 12. It's already 12:10. I think I need to go and sleep, because I have service tomorrow. Yeah, I have service tomorrow by 8:20, and I need to wake up early. So I think that's that for tonight. You guys, I wish you guys the best of luck in your Jamb exam. If you have not subscribed to my YouTube channel, now is the best time to do so. Subscribe to my YouTube channel and turn on the notification bell. I believe you have gained something tonight. So if you have any issues or you want to come back to this class, no problems. Just check my YouTube channel. You will see I will drop the recording here on my YouTube channel. I'll drop the recording. No, we'll continue. I cannot continue now. I'm going to church tomorrow. Are you good in electrolysis? Of course, I do electrolysis classes. I've made certain questions solving electrolysis questions. I've made some videos solving questions on electrolysis already. You want to screenshot? Okay, I'm coming. Damn, what are the terms you recommend? Okay, for chemistry, I recommend Jamb mix. You can use it to practice. I also recommend New School Chemistry. Also, you can also get Lamlat Chemistry, even hidden fats. Teachers, please. Me, sir, I want to sleep now. I also have things I'm also reading as well. You know, I'm also a student, right? When is the next class? That's a great question. The next time I'll be coming live, probably next week Saturday. But I'll be dropping videos here on my YouTube channel. Yes, understanding chemistry 2 is good. But I'll be dropping videos here on my YouTube channel, like solving videos. I'll be solving different questions and I'll be dropping it. so you can always watch those ones. So if you want to screenshot, right? Yeah, you can only, this is it. If you want to screenshot, well, you can always screenshot. This is what you need if you want to screenshot. You say next week is far. It's because I'm also busy with school now. You people know that me too. I'm also reading. So screenshot this. I'll be dropping the recording also. I'll be dropping the recording of this video, so you can always come back to watch it. You can always come back to watch the video. So for you people that are screenshotting, this is it too. And this was where it started from. So if you have not liked this live, if you have not tapped on your screen, now is the time to tap on your screen. Just double tap on your screen or triple tap so that you can like the live. We are still at 54 likes. How do you want people that want to watch this thing to be encouraged to watch if people that even joined the live and gained from it did not really like the live session? It's not easy. So it is well. I'll see you guys when next. I'll be posting. I'll still post on my YouTube channel tomorrow. I'll post the 15 most repeated topics in biology Jamb exam. Yeah. Are you teaching organic? Are you going to teach organic chemistry? I've already taught organic chemistry. Check my YouTube channel now. Check my channel now. I've uploaded a very detailed video, 1 hour 20 minutes on organic chemistry. That's part 1. I'll be uploading the part 2 soon. I couldn't finish it in that video, but I'll be uploading the part 2 soon. Have you done videos on pH? I've not really done videos on pH. Do you people want me to do videos on pH? Okay, you want that, Abby? Alright, now no wahala. Should be expecting that on my YouTube channel soon. Should be expecting that on my YouTube channel soon. Hope I believe you people have read. You people have jacked all those acids and bases. You have jacked everything. You have jacked all those indicators. You have jacked all those different definitions. All the Chatelier acid, Lewis acid. You have jacked everything on Arrhenius theorem, everything. People must have jacked all those things. So people must have jacked all those things now. You say how to solve log theorem with a calculator? Yes, now. You should know this log theory now. Use log theory now. Use log theory for it. See, your eyes are closing already. I've been now. I'm just doing all of these things just to impact so that when you guys take your exam, people know that at least this guy helped me. Impact matters in life. It's not just life. This life, we only come to this life once. We only come to this life once, right? So if you come once, try to impact so that when you leave, people will remember that this person, it was a good person, it impacted me positively, or people that impacted people negatively. That's life. Metals and non-metals. Metals and non-metals. Metals and non-metals is more of things you need to be reading now. It's more of reading. There's no solving your explanation like that in metals and non-metals. You need to just read it. Read metals and non-metals. So it's not. I cannot sit down between metals and non-metals. It's just like a waste of time to me. When you can sit down and read it yourself. Nothing else. God bless you. Amen. Thank you so much. Easy, I swear. I wish I could have the type of brain you have. Make I'm your boy, I'm a small boy. It's God that is helping me. Me no get time for reading. Now you all do Jamb exam now. No be me now. So ask question on non-metal speech. I want to sleep, I beg. I want to sleep now. You don't want to, you don't like me at all. The chemistry is too much in the brain. No, not at all. Teach us log theory. Log theory is mass now. Oh, you push not stress me, I beg. Means that I want to rest. I want to be enjoying life. I want to, especially nitrogen. Okay, now. That means you must have read all those nitrogen cycle, all those nitrous oxide, nitrogen dioxide, all those ones, and their uses. Make una leave mass chem, I beg go. Thank you. I mean, no time always work. Just one board mass. Make in sleep. So good night, everybody. I'll see you guys tomorrow. Is it tomorrow? Today. I'll see you guys today in my video. I'll be uploading a video today on my YouTube channel. So if you have not subscribed, now you know why you never subscribe. So thank you guys so much. I'll see you guys in the next one. Ciao. Peace out. Where do I end the live, Seth? Where the thing there? Where's the button?